All right, we are going to look at some regular figures, finding the area. And when you're doing the area of a regular figure, a little bit different. 1/2 the apothem times the perimeter. Now, if you've gone on the Khan Academy, he does it a little bit different than what I'm going to show you today because they don't go through all of the regular figure stuff that you guys have already been in through. All right, so looking at it, starting out with this triangle, it's equilateral and equal angular. So each of the angles is going to be 60 degrees. An apothem is going to be the length from the center of the circle of the inscribed perpendicular to the opposite side. So that's going to be our apothem. Now, it's actually a perpendicular bisector, which means that it bisects this side. We're going to call that side S. So then this length right here is going to be S divided by 2. And then, of course, this last side of the triangle is going to be the hypotenuse, because remember, it is a perpendicular bisector. We also have this length from the center drawn to the vertex. That's going to be a bisector of that angle. So then what we really end up having is a right triangle, but a special right triangle, our 30, 60, 90. And remember, we had two rules for 30, 60, 90. The hypotenuse is equal to twice the short leg, and the long leg is going to be equal to the short leg times the square root of 3. So we're actually going to be able to use those rules for this particular triangle, depending on what information you're given. So let's say we were given the length of a side. We'll say that side is equal to 4. S, right, divided by 2 then, this length is going to be 2. Most likely they'll give you the hypotenuse of this triangle as well, or something, some way to figure that out. So the hypotenuse, or the radius, is going to be equal to 4 for this case. Then you could take these things and figure out what the apothem was going to be by using these particular formulas. So same thing is going to be true for a square. Center of the circle that's inscribing the square, perpendicular, is going to be a apothem. You're going to have the radius of the circle, which is going to bisect this side. And again, this side of the triangle is going to be exactly the same length because we have a special right here as well. This is a 45, 45, 90. Remember, we had a law there. The hypotenuse is equal to the length of the leg times the square root of 2. So we are saying that this is the apothem. Well, this length is going to be exactly the same. And then this one is going to be the length times the square root of 2. So you can see how that's all going to work when you're talking about regular figures. And each regular figure is the same. Of course, some are going to be easier than others, basically because if they have a special right triangle involved, like we are having on these that I'm showing you today, you don't have to use trig functions, you can use the special rules. So for the hexagon, we're going to again have a 30, 60, 90 triangle, except this time the 30 angle is up here, 60 is going to be here, so you still are going to use your 30, 60, 90 triangles. Remember, Now that you have these, the area formula is going to be equal to 1/2 the apothem times the perimeter of the regular figure. Hopefully that helps. Got an assignment for you to do, so be looking at that. Also have the nets, which we're going to start looking at, and finding the surface area of certain things. So good luck.